Alright, so let's now go back to number 1 there, where we have dst dsk, and we're looking at the magnitude of that, and that's the same as we have the product dsj minus 1, yeah, and it goes from j equals to k plus 1 to t. So I take the magnitude of that, yeah, and that is smaller or equal than, here again, from j is k plus 1 to t of gamma lambda, yeah, and this is then smaller or equal than gamma lambda to the power of t minus k, yeah. Just intuitively remember, we had our cost C4 here, then we had Y4 predict, S4, S3, S2, S1, and here you had your W. Yeah, so if gamma lambda is smaller than 1, your gradient can vanish. And if gamma lambda larger than 1, your gradient can explode. Yeah. Basically, the worst condition is where when t is equals to large T. In this case, this will be t is 4, meaning t equals large T in this case. Yeah. And when k is small, yeah, then of course here you have many terms. What does this mean? Well, it means that you're calculating your C4, because here you are at time step 4, and you look at the influence of all the S's, even going back to S1, yeah, also S2 and S3. So the more terms you have, the more you risk of vanishing and exploding gradient. So this is where we ended, yeah. If gamma lambda smaller than 1, you have a risk of exploding, vanishing gradient. When gamma lambda is larger than 1, you have a risk of exploding gradient, yeah. Especially when this exponent is large. When is the exponent large? When t is close to big T, and where k is actually very early into the network. Now remember, here we have t, and here you have your start, and here you have your k's, yeah. So if you go all the way back here, and you're here, then of course you run that risk. So it's easy to know now, how do we solve it? How do we solve? Well, if you're close to t, don't go all the way back. Yeah, so you limit t minus k. That is one option. And the second option is to normalize. Yeah, so you have your gradient with respect to w. You divide it by the norm of that vector. Because you're now really interested in the value of the gradient. You're interested in the sign of the gradient. What do you gotta go, left or right? Yeah, so one good trick is also to normalize.